my gosh, it seems like ages since I last did this, but I've only skipped 1 week. Good evening. This is Pop Astro Live, and tonight it is a Jupiter special. Normally we have blue banners, but tonight I've tried my best to get the little banners across the bottom pretty much roughly the same colour as one of Jupiter's amazing dusty red bands. So, housekeeping first. How are you? It's been a weird old day here on Anglesey. And first of all, actually, I need to slightly apologise because basically Anglesey is a wonderful tourism island. And when I first started doing this, it was lockdown and the tourists weren't here. But I think with so many tourists in between here and wherever the internet comes from, I don't really know where the internet comes from, really. Our bandwidth is very low. So although we're an amazing dark sky island, I'm really far right out on the west tip. This is the mainland over here. So I'm about as far away as you can possibly get. I'm in some of the very last residences right here in Triada Bay, in this little bit here. So the internet has got a lot of hard work to do. So hopefully I'm not too pixelated, but fingers crossed we're going to have a good quality stream tonight. Do let me know. Please start commenting. This is an interactive show, so get firing away in the comment section. I love your interaction, your encouragement, your questions. We have got astronomers on standby waiting for your questions. And let us not forget to plug the mug. Plug the mug, plug the mug, plug the mug. This is like a Mark 1 mug. Let's have a look at some of the mugs that we have got available in the SPA shop. Share screen. I think it's that one. Let's have a look. This might work. Wow. Check us out. So you can see, very pixelated. I am so sorry that it is pixelated. I am so sorry. This is just the bane of my life at the minute. I make my living doing these live videos, and now the tourists have come back. What is a girl to do? What is a girl to do? Just listen to me anyway, and close your eyes maybe. Pretend we're a radio show. Put cloth over the laptop like you would put a cloth over a parrot to stop it from talking. So as you can see, we have got our mugs here. Aren't they good? I know Paul Sutherland has been working hard on these comedy astronomy mugs. Astronomy is looking up. I've got stars in my eyes. What did they say? Can we scroll up there? I think my favorite one is the one with the Milky Way that says, I make my drinks the Milky Way. Not very responsible if you've got a lactose intolerance, that mug. So be careful. May contain milk. It's time to mug up on Mars. Go Perseverance. And another great one, I'm just going through at phase. Now, this is all available on the Pop Astro shop. So go to popastro.com and you can join me in a virtual cheers, because the SPA mug looks good though, doesn't it? Of course, it's only water. Screenshot very clear. Oh, that's me then. Right. Okay. Thank you for the technical feedback. I apologize about the duff signal. Like I say, I'm so far out west. Anyway, tonight, it is a Jupiter special. And I got a glimpse of Jupiter last night. I didn't looking out the window. It was that way. It was that way. In my little 80mm Celestron, it looked like about as big as a pea. It was absolutely fantastic. I was just going to bed and the BF called and said, come and look at Jupiter. I taught him how to use this. He knows how to use it. And so we had a really good nosy at the big old gas bag, as I quite like to call him. And you couldn't really see much detail. You could just make out the upper top red stripe and 3 of the moons last night. And I reckon that those little tiny flecks of the Galilean satellites that you can see are pretty much the limit that a human eye can see down to. I don't know many things that are smaller than one of Jupiter's moons when you're looking at it. So, such a big planet deserves a big show. improving. Evening, Vicky. You are pixelated, but share screen is gorgeous. Thank you very much, Robin. We'll share the screen again. Might as well. Look, just to show. Where's it gone? Plug the mugs. Plug the mugs, man and woman. There you go. There you go. Just to prove. They're great, aren't they? They are our SPA mugs. Please order generously for any astronomer friends that you may have. Get your hoodies as well. And of course, our new range of t-shirts. So, John French, thank you. He says I'm improving. What's improving? Greetings, lovely lady from London, Helena Murphy. Thank you, Helena Murphy. Good evening. My mugs arrived this morning. My wife loves the Milky Way one, her favorite object. What, the Milky Way is her favorite astronomical object, or it's her favorite object in the world? She's obviously not very materialistic. Excellent. Great to hear that you've got our mugs, Michael. So on tonight's show, we have got 4 cracking guests. Usually we only have 3, but I've pulled 4 out of my magic space hat tonight. We have got Dr. Tom Stallard, Associate Professor of Planetary Astronomy. We've got Jupiter Aurora expert, Affelia excuse me, 1 minute, my screen has just gone off. Wibisono, she's a PhD student. We have got David Graham, SPA Lunar Director, who tonight is moonlighting with Jupiter, and Alan Clitherow, SPA Planetary Director. So let's get Dr. Tom Stallard on. Hello, everybody. Hi, Sandra Grace. I bet you were excited about Perseverance launching yesterday, weren't you? Because you are the biggest Mars enthusiast that I know. Wonderful. Thank you very much for joining us this evening, Sandra. Okay, Tom, we're coming over to you in 3, 2, 1. There he
Hello.
is. Hi.
Hi.
We both live out in the sticks, and it's so beautiful and wonderful. The dawn chorus, no sound of motorways, but try to have a live Zoom call with somebody and you're doomed, aren't you?
I know. I'm sorry.
We're so sorry that we live in the countryside. It needs sorting out. I keep on saying instead of building HS2, they should just give us all amazing internet.
Yeah, it would be much better.
Are you receiving me quite clearly? It sure would be. It sure would be. So thank you very much for coming on this evening, Tom. Tell us a little bit more about what you do.
So I use the largest telescopes in the world to look at the gas giants, to look at the top of the atmospheres, the very thinnest part of the atmospheres of these worlds, to try and understand how they interact with the surrounding space environment and all of the deep and massive atmospheres underneath. And you've got this little tiny thin wispish boundary layer that sits between the vast magnetosphere around it and the immensely powerful atmosphere underneath it. And those two massive systems try and push and pull this tiny thin bit of atmosphere however they want. And I watch the perennial battles between the two in this thin little layer at the top.
That's what I love about doing this show, because I had no idea that battle for existence was even taking place. That is just so fascinating. So I'm just going to put you full screen now, and maybe your picture might be good or maybe it won't be, but I'm going to disappear, but you'll still be able to hear me. Okay.
Brilliant.
Hey, we've got full screen time. Okay, so let us continue with the interview. So it says here that you were the first person to ever know the location of Jupiter's magnetic equator. Wow.
That's right. Absolutely. We all know it in incredible detail now because of the Juno mission. Juno has been orbiting in a polar orbit around Jupiter in order to do exactly that, to measure the magnetic field in incredible detail. The lead PI on the instrument that is doing that, the mag instrument, is a guy called Jack Canerney. And 20 years ago, Jack Canerney was interested in measuring the magnetic fields using the aurora. So he took a whole slew of observations of the aurora in order to basically measure a single dot in that massively complicated aurora, and that's the footprint of Io. So the moon Io has a direct auroral footprint, and that allowed him to measure the magnetic field in pretty amazing detail at the time, much better than you can get from just using spacecraft, especially when they're much further away from the planet than Juno is. Basically because the surface of the planet is really close to Jupiter, obviously, is right there, so it's measuring the magnetic field in a lot more detail. So he had this massive data set that he released to the community, and I was playing around with it, trying to come up with science ideas. I didn't really know why. I had this kind of idea about looking at the aurora and trying to use it to understand changes depending on the direction of the sun or something like that. I never really got to the end of that study. I've still got to write that paper, but I plowed on, even though there were 13,000 images. It took me about 4 months of watching TV, clicking on the screen, just to fit the limbs and get everything aligned. And I just started to get very disillusioned with the whole process, because that's a lot of data. That's a lot of different pictures of Jupiter to look at over and over again. But I went on. I don't know why I went on. Something about it just really pushed my buttons and told me I had to keep going. So I did. I kept going. And then I wrote a paper based on some of the observations we made near the aurora. That's a paper that I wrote about a giant dark weather region that seems to be at the top of the atmosphere of Jupiter, which was a lot of fun. And most of that was based on some of the big telescope data we took recently using spectra from Chile. So there's a big telescope, the Very Large Telescope in Chile, that we used to analyze that. But I thought it'd be good to have some of these images as a way of backing it up, because that looked back 20 years earlier, and it allowed me to show this feature was a much older feature. But there was a really annoying aspect of that, which is the filter that was used with that observation wasn't very good filter. It wasn't very narrow filter. So there was a lot of weird lower atmosphere light coming through, as well as the top of the atmosphere. And so all you saw were these atmospheric bands in the equator, and I just wanted to get rid of them. I wanted to get a nice, pretty clean image so that I could show off what was going on around the aurora. So I wrote a program that just averaged the weather bands in the lower atmosphere, and I just wiped them off. And instead of a perfect, clean picture of the background of the bottom of the atmosphere, which we always thought was very boring, there was this weird worm, this weird wiggly black worm in the middle of the data. And I looked at it for maybe 5 or 10 seconds, and immediately I knew what it was. I think I even said out loud, "That's the magnetic equator of Jupiter." We didn't know that there would be a signature in the ionosphere of the magnetic equator of Jupiter. We know that there is for Earth, but no one had predicted that it would exist. But there it was. And it's quite a strange feeling to know that not only are you seeing something that there are space missions to try and understand, and that no one had ever expected to see, but you immediately knew what it was. It took me maybe 3 years to prove to myself and other people that actually that was what it was. A lot of people were very dubious about the result, but finally convinced everyone that actually it was real. But I knew in that instant that that's what it was. So it's very odd that you could see magnetic fields writ large on a planet like that, but there it was. And it's really the best way to see any magnetic field around equator, around any planet. It's the best image we ever have had of the magnetic equator of any planet, including Earth. It's much harder to see Earth. Vicky, are you there? Hello? Well, I don't know what to do now.
Tom! Can you hear me? I think Tom's internet might be a little bit poorly. Are you getting me there, Tom? This is a sad day for astronomy. Get me? Oh, back in the room. We're both battling poor internet and bad weather here on Anglesey. So, how much can you hear me now?
I can hear you really well now.
Me? Oh, good. Yes, okay.
I am indeed.
You can hear you, Tom, but not Vicky. Okay.
Oh dear.
Right. Okay. Well. Oh no! What are we gonna do, everybody?
Vicky, you didn't tell me I'd have to fill.
Right.
I mean, I can keep talking if you want. I'm happy to keep talking, but I wasn't sure that anyone else could hear me. Sure. Okay.
Yeah, keep talking, Tom.
So, one of the other questions that you were supposed to ask me, if I can remember rightly, was the work that we do to look at the atmosphere of the top of the atmosphere above the Great Red Spot. So the region I look at is very high up. Generally speaking, the temperatures don't move up and down through the atmosphere all the way, because at a certain point you don't get overturn in the atmosphere anymore. You don't get vertical mixing, and everything starts separating out into whatever is heaviest and whatever is lightest. And the region that we look at is at the very top. It's the very lightest region. So it's really hard to heat that region. So the expectation has always been that that's going to be completely decoupled from the underlying atmosphere. There's no way that the underlying things will heat it up. But there's been this big question for a very long time about the equatorial regions. We know from spacecraft missions that that region is actually really hot. It's as hot as the aurora region, which is really unexpected. And we don't really know why that is. It's been a perennial problem that we've been trying to solve for 20 years or something like that. When you look at the Earth, it's not a problem at all. The Earth, the aurora drives energy into the poles. It causes superheating there, but then that heat then flows like a wave all the way through the planet. And you see the whole of the top of the atmosphere ringing like a bell as heat moves from one pole to the other and back. But that doesn't happen at Jupiter because Jupiter has such a strong spin that it traps all of the heat at the poles. In fact, it's almost like a refrigerator. It draws energy out of the equator and should make the equator cooler, but the equator is really hot and we don't know why. So there's always a mystery. How do you heat the equator up when it's supposed to be getting colder as a result of the aurora drawing all of that heat out? So we happen to be observing the equatorial regions at the same time as looking at the aurora. We had a scan across the whole disk, and we were looking at the north and south aurora at the same time to try and understand how they differ from each other. And we were looking at the equator all the way through the equator at the same time, and that observation happened to move in front of the Great Red Spot. So a colleague of mine, James O'Donoghue, had, when he was a student, was looking at that data and showed that that region appears to be really hot, crazy hot compared to, it's even hotter than the aurora. So just the area immediately above the Great Red Spot is really very hot indeed. So that suggests that there's something about the Great Red Spot that is making the top of the atmosphere glow at incredible heat. And we couldn't really understand what that was because there's been a lot of models of the atmosphere, and they'd never predicted that it would heat up the top of the atmosphere in that way. But then we started looking at some of the recent research done for the Earth, especially on shorelines, where they see the top of the atmosphere much hotter along the shorelines, basically as a result of the noise of breaking of waves on the surf at the ocean, and also on the edges of mountains. As the winds blow through those mountain regions, they cause a lot of sound, and that sound propagates in all directions. So it tends to diffuse as it propagates horizontally, but as it moves upwards, it's able to propagate up into the top of the atmosphere. But as wavelengths get carried to thinner and thinner air, they can't support it. In the same way as wavelengths on the ocean can't be supported by water that's getting thinner and thinner, as you get close to the shore, long waves break and they cause all of this energy deposition. So these long ocean waves reach the shoreline and they break on the shore and cause all this energy, all this sound and surf. The same thing happens as waves propagate upwards in the atmosphere. So what we think is happening is the enormous hurricane sound of the Great Red Spot as it whips around in the lower atmosphere is causing huge amounts of sound energy, compressional energy in the atmosphere, and that's propagating upwards into the top of the atmosphere. As it reaches the top of the atmosphere, the air is too thin to carry that wave anymore, and it just breaks like the shoreline, and it dumps all of the energy. And we think that that might be driving this heating in the top of the atmosphere, which is fascinating because it gives us possibly a new source of energy. We recently had colleagues in Japan who confirmed that they were seeing heating in that region in the same way. So that was really a positive step because these regions are quite hard to observe. So it was really nice to see that additional heating.
So the spot is a big old noisy thing then?
Exactly. I mean, it's exactly what you would expect, right? You think of how noisy a hurricane is on Earth, and you think that that's a hurricane that's twice the size of the Earth. It's going to make some noise.
Wow. Is there any way of monitoring the sound of it?
Well, if we could devise a space mission to do it, right? We could fly into Jupiter. We could have some kind of plane that flies through that region. Sure, it would be very easy to measure it if you could get there. The problem is, of course, getting there and getting into the top of the atmosphere in that way. There are now missions that are starting to do that kind of thing. We've just seen of a Mars mission where there is a planned mission to Titan with an octocopter that's going to fly through the atmosphere. So potentially in the future, maybe we will see some kind of probe that will sit, a balloon or some kind of helicopter that will sit in the atmosphere of Jupiter and be able to measure things like that.
Karen Martin is asking, how hot is the GRS, the Great Red Spot? What temperature is it? GRS.
Well, I'm not a lower atmosphere person, so I can't tell you how hot the lower atmosphere is. What I do know is it's this giant system where it's kind of like a storm where you see on the horizon storms that have those really high clouds. It's drawing those clouds up. It sits vastly higher than the rest of the atmosphere of Jupiter, so it sits way above most of the clouds on Jupiter. But what I can tell you is how hot it makes the top of the atmosphere, and that is about 1,500 Kelvin. So it's incredibly hot. Now, temperatures are a bit weird at that height anyway, because it's not exactly the same as normal temperatures because the air is so thin, it doesn't necessarily transfer energy in the same way. But that is at least 1.5 times hotter than the aurora makes the atmosphere at that top level. So incredibly hot in terms of the wispish little thin layer that I look at.
Okay, so how does measuring the shadow of Ganymede on Jupiter tell us something about the ionosphere and the physical nature of the ions there? Is definitely the most technical question I've ever asked in my life.
Well, you could rephrase that, I guess. I mean, the way that we phrased it when we sold it to the telescope as a proposal was that we were chasing shadows over Jupiter, and the reason I wanted to do it really was because how cool is that? I mean, how cool is it to look at the shadow of Ganymede on the disk of Jupiter? And it was such a good and cool thing that we broadcast it live, I think about a week ago. So if people want to look for at the Royal Astronomical Society webpage, YouTube channel, they'll see a 6-hour recording of us observing live. So if you want to see some live observations in action, you could go there and look at those. And we basically did a webcast about why it's really cool to look at the shadow of these giant moons as they cross the disk. And the reason it's important is that we're interested in the ionosphere, and down in the equatorial regions away from the aurora, the ionosphere is made by the sun. So the solar EUV light hits the top of the atmosphere and breaks apart the neutral atmosphere into ions and electrons, and it generates this region where currents are able to flow, and that's why we're really interested in them. But what we don't know is really any of the timescales for how quickly it gets made and how quickly it gets destroyed. It's a very hard measurement to make in the lab because the species that we look at is incredibly reactive. So we don't really know how it works in the lab at all. And it's a really hard measurement to make in space, because the best way to do it is to watch the motion of the ionosphere from the day side to the night side. So on Earth, we can measure what the ionosphere looks like on the day, and we can measure what the ionosphere looks like on the night, and we have a really good understanding of how it decays away and then how it gets ionized again on the day side. But of course, we're not on Jupiter. We can't see the night side of Jupiter because we're way too close to the sun. So there's no way of really seeing the night side. I tried all sorts of ways. I kept trying different things. I tried Cassini. Cassini flew by Jupiter in 2000 and was able to see the data in the night side. And I wrote a paper looking at that, and it didn't work. I tried the fact that the Earth isn't quite aligned with the sun. Sometimes you're looking this way and sometimes you're looking this way, and maybe you get a slither of the night side on either side. It didn't work. So I had to come up with a way of figuring out how to see the night side from the day side. And that's basically what you do when you go into an eclipse. If you've ever been in an eclipse, the moon moves in front of the sun, all of the birds come and roost in the trees. They're singing because they think it's the end of the day. It all gets dark, you get a chill, and then suddenly the sun appears and it's daytime again. The difference is, because of the way the moons are much closer than our moon is, and the sun is very small compared to the sun at our distance from it, and some of the moons move almost the same speed as the planet rotates. So Callisto has an extinction of about 25 minutes. It's in darkness for 25 minutes if you're on the surface of Jupiter. And when Ganymede goes past, it's in darkness for about 50 minutes. So it's nearly an hour of complete darkness. So for us, that's as good as a nighttime signature as you can hope to get. So what we're doing is we're looking at the ionosphere, and hopefully we were hoping to see it get dark and get bright again, because it's disappearing and then reappearing. And I mean, we definitely saw it. If you look at the observations we were making last week for Ganymede, there's a big old hole in our data. You can see ionosphere, then you can see nothing, and then you can see ionosphere. So after months of future processing and detailed science work, I'm going to turn that. It goes away and comes back into an actual scientific answer for exactly how long it takes to destroy the ionosphere and come back. But it's incredible that, instantaneously after an hour of observing, you can actually see the ionosphere disappear and come back, because it's in darkness, because there's no sunlight to make it. I've lost your sound, Vicky. I know.
Sorry, Tom. How's that? Am I back?
There you go. Yes,
I was going to say, I think that might be one of the most exciting and interesting talks I've ever heard of any astronomer. Have you ever done any talks for the SPA? Because I think we'd like to have you.
I haven't, but I'm more than happy to.
That was amazing. I learned so much new stuff then. And I was chuckling to myself when you were talking about trying to see the night side of Jupiter. And it couldn't have been that long ago that I remember looking in the mirror and wondering if I could actually turn around quick enough to see the back of my own head. We've all tried it. Tom, it's been an absolute pleasure. Where can people pick you up and follow you, please?
You could search for Pro Astronomer on Twitter. You can search for it on, all one word. It's pretty fancy, isn't it?
You got the good handle there.
On YouTube as well.
Pro Astronomer.
Got in early.
You did. You were an early adopter.
On Twitch, I think I have that handle. Yep.
Well done. That is awesome. Okay, the man with the handle, Thomas, thank you very much. And we'll give him a follow. And thank you so much. And maybe the SPA will be in contact, because that was a truly amazing talk. Thank you so much.
Brilliant. Thank you so much.
Go and enjoy your nice rural ambience now.
Thank
Bye.
you. Bye-bye.
Bye. Blimey, that was really amazing. I'm quite flabbergasted after that. It's amazing when you speak to experts just how little you actually know. isn't it? Right, so coming up now, we have got our next interview host, a guest, should I say. We have got Alan Clitherow, SPA Planetary Director. So let's get him on. Are you ready to come on, Alan? Last time we had Alan on, the minute I announced, oh no, it was David Graham who had the power cut. I'm sorry. Yeah, we've not tried Alan yet. Here we go. Here comes Alan. 1, 2, 3. Hi, Alan.
Hello there. How's things?
Good. Hopefully the technology will hold out tonight.
Yeah, I'm hoping so. Like you're in rural North Wales, I'm in rural Scotland, and I'm just hoping there aren't too many people watching Netflix between my house and the telephone exchange.
Imagine how many millions of people are watching Netflix in between me and you, Alan. It's a lot, isn't it?
Yeah, it is. Yeah, we were a little bit slow with the chat last time. Hopefully it'll hold up and you're getting some decent pictures and sound. I was going to say that was an amazing talk that we just saw. So you're actually moving from the sublime to the ridiculous now, but I'll do what I can and answer your questions if you have any.
Oh, well, I tried to, because we've got 4 guests, 2 mega experts and 2 from the SPA. I tried to pace it. So, well, how was that for a warm-up act? I don't know how you're going to follow that one, Alan.
Yeah, I think I'm going to follow that.
Okay, so, well, first of all, well, I'm not going to sift through the pages, but you are the Planetary Director of the SPA. Look, I got all the magazines back from my mum's. How's that? For a plug. So tell us about what your role is at the SPA, first of all, please, Alan.
Well, really, all I do is collate the observations that I receive from the SPA members, those particularly who are in the planetary section, so that I can put together every 2 months a section report on what they've observed, what the implications might be, maybe give some help and advice in planetary imaging or planetary observing in general. And if you want plugs, I'll plug the SPA website, because if you go into the planetary section there, you'll see the section director's reports. Usually they're full of lots of pictures showing what the members have produced, and I think they're quite interesting. And also in there you'll see a forecast of what's coming up for the next couple of months. So I've just put up August and September, what to look at in the planets. That's basically
so
it.
Jupiter. Okay, so this is also in our magazine that comes out every 2 months, which we will chat about in a little bit. Now, Jupiter is riding high, looking resplendent at the moment, isn't he?
It is. Yes, it is. If you want to see Jupiter, now is a very good time. It's rather low in the sky, which is a little bit of a shame. It's because the plane of the orbit that all the planets follow, the plane of the ecliptic, is low in the nighttime sky during high summer. So it's unavoidable that the planets, if they're in the south in the summer, are going to be relatively low. And Jupiter is low, but you can still see a fair amount of detail on it. You were talking yourself that I think you said 80mm telescope just over your shoulder. You could see the major bands on the planet and also the Galilean moons. And as I said, it's a good time because Jupiter reaches due south for this week and next week or so, around midnight British summertime, local time. And just for information, Saturn follows about 20-25 minutes afterwards due south. So that's at its highest point in the sky around midnight. So you can follow it more or less from the moment it gets dark, when it rises in the southeast, transits due south around midnight, and then moves into the southwest and sets. So you can see it for most of the hours of darkness, even though up in Scotland the hours of darkness are fairly short at this time of year.
So obviously there's going to be lots of newbie astronomy types watching.
Yeah.
And the main number one question is, what telescope is best?
Yeah, the best telescope for observing the planets is always the one that you can't afford, because you want, ultimately, if you're going to get into planetary observing, to get the highest resolution, the tiniest detail that you can see on the planets, you want to get the biggest telescope you can. But that's not to say that you shouldn't try looking at it with whatever telescope you've got. You've got that 3-inch telescope over your shoulder. I've got a 4-inch refractor here. I don't know if you can see it. Try and show it into the picture a little bit, which is basically just the big brother of the one you've got over your shoulder. And I tend to use that telescope when the seeing isn't particularly great, because the biggest limitation on either seeing or photographing planetary detail is our seeing our own atmosphere between us and the target. If our atmosphere is turbulent, then you're never going to get terribly clear views. If you get a nice, steady, calm night with a high pressure region sitting over the UK, if you're observing from the UK, and you've got still air or very little air movement right the way from ground level all the way up to over 30,000 feet, you can get superb pictures. And it's on those nights that the big telescopes really pay dividends. Perhaps the best planetary telescope I ever looked through was the 15-inch Newtonian that Patrick Moore had down in Chelsea on the south coast. But he had a little, it was the Chelsea bubble, the Chelsea triangle, people called it, because the weather down there was often very good, which is why he sighted himself there. And he also had a big observatory to put a big telescope in. Most people don't have that, but you can see detail with small telescopes, as you've already described with your 80mm refractor.
So, okay, well, thank you. You've given me some inspiration to use my little guy over my shoulder here. So what's happening on Jupiter at the minute if anyone does get their telescope on it?
Yeah, there's a number of things, and I'm a complete amateur, so I'll plug amateurs. There's a guy called Clyde Foster who observes from South Africa back in the end of May. I think it was the 31st of May, around there. He observed, I think he photographed a little dark spot in the southern part of Jupiter's atmosphere, south of the south equatorial belt, the south tropical zone, which hadn't been seen before. And it's interesting. The great thing that amateurs can do is devote time. They can provide time that the professional observers can't do. Amateurs can go out night after night after night and look at Jupiters. The big professional observatories have got plans for months ahead of what they want to look for, so they cannot look all the time. So they often rely on what amateurs find to then book telescope time to look at it. And in this case, I'm sure you're aware, your listeners will be aware of the Juno probe going around Jupiter at the moment in its huge elliptical orbit. They were actually able to target this little spot, which is called Clyde Spot, for study, to see exactly what it was as the Juno probe went over it the last time it went past. And some pictures of that were published, very high resolution pictures by NASA. And that's just one example of what amateurs can do. But the North Equatorial Belt, one of those two major belts you discussed, is having an outbreak at the moment. It's expanding, it's very turbulent, it's very active. This happens about every 3 to 5 years. The South Equatorial Belt is quite split, it's quite small. It's actually broken into 2 or 3 smaller belts, depending on how closely you can see it, the resolution you can get on it. And obviously things like the Great Red Spot, amateurs are looking at it all the time so that we can judge its size, because in the last few years it appears to have been shrinking quite noticeably. And that's obviously an ongoing area of study. And again, amateur pictures can feed into professional research. So there's a lot going on at Jupiter at the moment, and it's well worth observing. And if you're like me, photographing it.
So your bandwidth is cracking a little bit, so we will constantly just tell us about how you can find out more information about observing the planets, please.
Well, obviously, if you go to the SPO website, there is, in the planetary section, details of what's coming up on all of the major planets for the next 2 months. I've just put that on the website, so you can have a look. For instance, coming up at the moment and into early August is a very good time to look at Mercury in the morning sky. Venus is terrific in the morning sky. Mars is getting better and better. Details like that, where to find them, when they're rising, how big and bright they are on the SPA website in the planetary section. And I'll just do a little plug, because I actually come at this from the astrophotography side of things quite often, is I've just put on that same site, within the reference section, a PDF document on the basics of planetary imaging. So anybody who's interested in having a go, basically it's just demystifying all those technical terms that you hear bandied about, and explaining equipment and what cameras are useful and how to use them and what software is useful. Terrific free software for planetary imaging, written by amateurs for amateurs. So
that is amazing. Thank you so much, Alan, and thank you for putting so much effort in on behalf of everybody who enjoys the magazine and the labours of your love. Thank you so much. And that PDF is downloadable from the SPA page, yes? Yeah, from the planetary section, within the reference section of the planetary section. So you just search for your... What a head start if you're only just starting out in planetary imaging. Thank you so much, Alan. We overcame the tech gremlins. Onwards now to my next candidate. I'll see you later. Thank you very much. Bye. Bye. Thank you, Alan Clitherow, everybody. Yes, Steve Fractals. He's in pieces. Great info. Thanks, Alan. He's in bits and pieces. Steve Fractals, like the name. Right. Okay. We are now going over to a PhD student who got in touch with me this week to say that she would be more than happy to come on board and do a piece about Jupiter. And she sent me some samples of her work. And I was eating my lunch over a 6-minute YouTube video, which you will see on the SPA website, about the aurora of Jupiter. And it was enough to make me stop eating for at least 30 seconds, and that is saying something. So we are going to bring Affelia Wibisono on right now. Here she comes. Hi. You've been waiting so patiently since 8 o'clock, Affelia, haven't you?
Oh, I've just been watching the show.
It was good, wasn't it? I bet you've learned a few things tonight, haven't you?
Yeah.
So whereabouts are you tonight then?
I'm in Southampton today. Yeah, I'm usually in Surrey, because that's where, I do my work at Mallard Space Science Laboratory. But before everything shut down, I thought I'd go and stay with my parents. So that's where I am.
How have you been getting back on living back at home?
It's all right.
Yeah.
I mean, some things are good, others not so good, but yeah, it's fine.
I particularly enjoyed your 6-minute YouTube video about the aurora. That was a very enlightening video.
Oh, great. Thank you. I'm glad you enjoyed it.
So I don't know how your internet is tonight. Are you in a land of decent internet tonight?
I think so. Yeah, I haven't had any problems.
Excellent. So I'm going to make you full screen now and fire away some questions related to Jupiter, if that's okay. There, okay. You're on your own now, love. You're on your own. Okay. So Jupiter, from the video that you showed me, actually, are they blue, the aurora, or is that just kind of like image intensified?
Yeah, so the video that you saw was in ultraviolet. So of course our eyes can't see that. Okay. And I guess you can give it any color you want, but Hubble for Jupiter's aurora anyway tend to use blue.
So what causes the aurora on this amazing largest planet in our solar system?
Yeah, well, the aurora is just the result of collisions between charged particles and the gas molecules in the planet's atmosphere. So for the Earth, the charged particles come from the solar wind, which is released by the sun, and usually they are stopped by the Earth's magnetic field. So they don't have direct access to our atmosphere. And if there's a strong gust of solar wind, the solar wind particles are more energetic, and they can actually get inside the Earth's magnetic field and then interact with the atmosphere to give us the aurora. Jupiter's is quite similar, so it's also got a magnetic field, like you've heard from Tom, and is really strong. But what's different is that it has a second source of these charged particles, and that's Io. Io is really volcanic, hundreds of active volcanoes on it. Every second, it releases 1,000 kilograms of material out into Jupiter's surroundings. And usually, actually, they start off being neutral. And after some time, they get charged, and then they're accelerated into Jupiter's poles to give us the aurora. But what we don't know yet is how they're actually accelerated into Jupiter's poles. And that's one of the things that I'm trying to find out, and some of my colleagues are trying to find out as well. But Jupiter actually has lots of different types of aurora. I mostly study the X-ray aurora. So Jupiter has infrared aurora, ultraviolet aurora, X-ray aurora, visible light, and actually it also gives us radio waves too. And Tom studies the infrared aurora. I study the X-ray aurora. And what I think is really cool about the X-ray aurora is that they're produced by electrons, so negatively charged particles, but also ions. So these are positively charged atoms. And the other types of aurora are even made by one of those things. So it's really cool to study what I think is quite unique. I think I saw a question earlier. I can't hear you, Vicky. I can't see you either. So I'm just going to keep talking. Someone earlier asked me, how do Jupiter's aurora compare to those we see on Earth? So that was from Paul. So one way is their size. Jupiter's aurora is huge. It's actually bigger than the whole Earth. It comes in different flavors, like I've mentioned. It's brightest in the UV. The Earth's is brightest in visible light. Jupiter's are much more powerful. So at any given moment, it gives off sort of a power that's double the total amount of electricity used by the whole of Europe over a year. They're different shapes as well. So on the Earth, we see them as ovals around the poles. Jupiter also has an auroral oval, but within that oval, you've got lots of things going on. On the Earth, it's dark within the oval. On Jupiter's, you've got emissions. Sometimes they're very bright, sometimes they flicker, other times they pulsate, and I guess the energies involved are also massively different. Jupiter's are much more energetic.
Bugger.
I can see you, Vicky, now.
Oh, I'm sorry. My tech is really being misbehaving. Can you hear me?
Yeah, I can.
Oh, thank you so much. Yes, I've been slightly distracted by trying to get my internet working. I'm sorry. Apologies to everybody watching. It's poor bandwidth. Thank you so much. You've got a wonderful ornament behind you. Would you mind holding that up, please? As a fan of anything to do with space memorabilia. Oh, we all want that. Where's that from?
I made it. I made all the planets. Yeah. There's another one. And
I recognise that.
Yeah, they're to scale to each other.
How do you make a massive, big, lovely, glossy Jupiter? It looks like it's made out of onyx or something.
So it's got a polystyrene ball heart, and then I've just put clay over it and painted over the top.
That's a real cool bit of craft. Can we see his aurora, please? The top bits there. Are they the kind of the blue bits at the top?
Oh, the blue bit. Yeah. So these are the poles. So you might have seen the Juno images of Jupiter's poles, and we were surprised to find out that they're quite blue.
That is one of the coolest little models I've ever seen. That is fantastic. Well, Affelia, good luck with your research. How can we follow you if we want to stalk you?
I'm on Twitter, so it's just Affelia W.
Okay, thank you so much. Right then, that is really lovely of you to come on and help me battle through the technological problems. Yes, that was so exciting. Thank you very much. Okay. Thank you and good night. I want a model Jupiter. Can someone please make me a model Jupiter? I would treat it very well. I would like that very much. Okay, so we've got our final guest of the evening. We are going to go over to David Graham. Now, the last time he was due on, which was maybe about a month ago, the instant I said, let's go over to David Graham, he disappeared from the feed, and maybe he can come on and tell us why. Here you come, 3, 2, 1.
Hello.
Oh, the internet didn't explode when I say your name. What happened?
Well, last time we had a thunderstorm, and the irony is that I thought the same thing was going to happen tonight because the sky looked all grey. Hopefully you can hear what I'm saying to you, but at the moment the sky outside my window here has gone the most amazing yellow colour, and I think we're going to have a real corker of a sunset from what I can see.
Maybe the weather might be okay tomorrow. Where are you this evening, David?
Well, I'm speaking to you from Barton in North Yorkshire, which is not far from Richmond, if you've ever been to Richmond.
Nope, I know that's where sausages come from.
Well, yeah, there is a sausage factory just down the road, actually. It's called Heck. By Heck, which is a bit of a Yorkshire.
Are they the vegetarian ones?
Oh,
I saw them. I saw the Heck sausages tonight, the vegetarian ones. David, it's really good to speak to you. Thank you so much. You've got some tough acts to follow tonight.
Right. Would you like me to say something about Jupiter?
Go on. How can you top all of that amazing content that we've just learned about the almighty gas bag? So,
well, you've learned about.
Sure, fire away.
Right. Well, I've been looking at Jupiter through telescopes since about 1976. And I think in that time, it's been around the sun at least 3 times and some more. So I've built quite a picture of Jupiter up over that time. But I want to say something that'll go along with what Alan Clitherow told you. Alan is very much, I think, an imaging amateur astronomer, which most people are nowadays. They tend to sort of like go into the imaging side with CCD cameras and that sort of thing. But that's not me. I'm rather old-fashioned. I still actually look at Jupiter through a telescope and put my eye up to the eyepiece, and then I sketch what I see. And by doing that over a period of time, you can learn a lot about the planet, because there's nothing quite like actually looking at something and then having to commit it to pencil and paper for learning about it. And it's the same way in which an artist learns about the subject. So what I'm going to show you, if we can all see that, hopefully, is this, if I get it in about the center of the screen, is a drawing of Jupiter. And this one was done about 2 years ago, but there has been some changes since then. And what you actually do is you spend about at least, I would say, up to about 20 minutes looking at the planet. And you're making a visual representation in your own mind of what you're seeing. And then you start committing it to paper. And you usually start by having what we call a Jupiter blank. And that's just an outline of the planet. And as you can see, it's not quite circular. It's slightly flattened at the poles. So it's best to have this thing pre-prepared. And then you start sketching on the main details, such as the equatorial belts. And if I can pencil them in, it's a bit difficult. These are the equatorial belts here, you see, those 2 broad ones. And they're pretty much visible in any size telescope. This is a drawing that was made through a 9-inch telescope. So it does show quite a bit of detail, and it's probably more detail than the beginner will see. What you're looking at there, that little thing there, is actually the red spot. Now, at the moment, that red spot does actually look red. It doesn't always. It sort of like tends to come and go where the colour's concerned, but it does look red. And that red colour is visible in quite small telescopes at the moment. Ooh, there you are. I'll pop it up there so you can see it again. Probably about a 4 or a 5-inch telescope will show the red spot as being red at the moment. But what you do is you can actually see, I come down here again, if I get it, yeah, is with practice, you begin to see detail in the belts of Jupiter, and you see like these dark projections and these festoons and these dark spots on the bottom of the belt. And then when you've actually started seeing those, what you'll notice is over a period of just a few minutes, they've actually moved. And the reason for this is that Jupiter spins on its axis very, very quickly. It does it in less than 10 hours. And what you can then do is you can estimate by the time, that's the time off your watch, at which these features begin to go across what's called the central meridian, which is halfway across the disk of the planet. And you make a note of the time. And if you can see it, then that's what I've done down there. Let's get that back so you can see it. Yeah. So there's the time. And next to that, I've calculated the longitude of the feature concerned. And the way to do that is you go to a publication such as this one. This is the handbook of the BAA, the British Astronomical Association. And in here, you've got tables telling you the central meridian longitude for each day of the year and how to work it out. And if you do that over a period of time, then you can actually start working out the drift of these objects in Jupiter's atmosphere for yourself. And you start working out the drift rates, which I think is something that many amateurs used to do once over, but in the age of imaging, where it's been replaced by measuring detailed positions off an image with a program such as JUPOS, it's not done so much now, but it certainly was the case once over. Other thing to tell you is that Jupiter, through a fairly large telescope, shows you a good deal of colour. That's something you can watch for. This is a drawing of Jupiter I made through quite a large telescope back in 1993. And you can see the red spot looking nice and red, and you can see that the belts and the zones look brown. But what you do see there in the center of the upper belt, that's the south equatorial belt, because south is at the top, as seen through an inverting telescope in the northern hemisphere, is 2 dark wedge-shaped spots. And what you're looking at there is what we call a revival of the south equatorial belt. One of the things that happens on Jupiter is it goes through these cyclic episodes of belts fading and then coming back again. Now, the north equatorial belt, that's the thick brown one seen here, that can become narrow, then it becomes broad, it can get very, very active, which it is at the moment. But the south equatorial belt can sometimes disappear altogether. So when you look at the Jupiter through a telescope, all you will see is just the one dark band. And that's how it was in 1976 when I started observing it through a little 3-inch refractor. So colour is something you can look out for. Major changes such as revivals of the south equatorial belt you can look at as well. But you don't have to have a telescope to actually see something happening with Jupiter at all. If you've got a pair of binoculars, and a lot of people have binoculars, I had binoculars before I had my first telescope. You can actually, if you focus carefully on the planet, rest them on the top of your car or something like that, or a fence post, look carefully at Jupiter, and you will see next to it some little points of light. And you may see up to 4 of these points of light, and they are the Galilean moons of Jupiter: Io, Europa, Ganymede, and Callisto. And if you look over a period of minutes, and that stretches into hours, if you've got the stamina to do it, you will see that they move their position. And you will certainly notice a difference if you're able to observe the planet from one night to the next. So that's something that you can do with a pair of binoculars. If you move up to a smaller telescope, as I say, like the one that you've got there behind you, Vicky, you will see the same thing again. You will see the satellites, and you will see some of the darker bands. And if you are lucky, what you may see is that the moons can move in front of the planet, and they can move behind the planet. When they go behind, that's called an eclipse and an occultation. When they go in front, you can go into what's called a transit. And you may see an actual satellite itself moving into transit, and then it gets followed a few minutes later by an intensely dark spot. And that is the shadow of the satellite. And these are all sorts of things that you can see through a relatively small telescope. But the thing is to try and get experience. Don't go to the telescope and just sort of think that I'm going to see all these things straight away, because you won't. You've got to take time. As my old mate Patrick used to say, you can't expect to see all these things at once, you know. You've got to spend some time observing them. And I suggest that you go night after night and you write it all down in your little notebook. And that's where you'll know all about Jupiter, nearly as much about Jupiter as I do. Well, I think that's enough.
The resemblance there was you're doing John Culshaw out of a job with that impression, mate.
So
David,
hopefully that's told you something about observing Jupiter with just a smallish telescope or a pair of binoculars. Because in itself, it really is.
The aspect of perseverance and being able to see it change over a relatively short amount of time, it's going to give me a lot more stamina at the eyepiece. And I've got to say, I've never heard of being able to calculate drift. So that was very impressive. But I think a lot of astronomers almost think that sketching is, I'm going to say, beneath them. I've suggested it to so many of my astronomy pals, and they're kind of like, oh, no, I wouldn't do that. Oh, I can't draw, or, you know, oh, it's not as good as imaging. But the few times I've ever attempted to sketch.
In an age before
you are missing
imaging.
out. If you don't sketch, yeah. So all you had, yeah. Got a slight delay here, sorry. So
but in the age before imaging, that's all you could do.
That's all we had. So sketching, I challenge every SPA member who's watching this to go and sketch something, because it helps you get your head around it in a way that just having it put down onto a digital image just cannot. And you feel very much more intimate with it. I sketched the Orion Nebula a couple of over the winter period, and now whenever I see it, it's like it's my friend. It brings you so much closer to the object, doesn't it?
That's right, it does. Yes, very much so.
Excellent.
Even if you don't think that you've got much in the ability as an artist or able to sketch things, give it a go anyway. Even if you just write notes in a notebook, you know, or in your diary as to what you've seen, you're making a record. And if you do that, you can actually begin to see that you're developing yourself as an observer.
And everybody can be taught. Oh, bloody hell, right. Oh, everybody can.
And there's a big peal of thunder.
Really? Good.
Well, we have very powerful.
Okay, well,
they have very powerful thunderstorms in the atmosphere of Jupiter.
I bet they do. I'm really struggling with a big delay. I'm struggling with the tech. I'm struggling. David, before you go, please give a big old plug to the wonders of the SPA. Look at this magazine you get every 2 months. What else do you get as a member, David?
Well, you can go on the website. Loads of information on the website. do a wonderful range of mugs that you can go out and purchase if you so wish. And they're starting to bring some of my favourite T-shirts back online as well. And I'm hoping that we might just see a few more of those.
Retro
there was astronomy looking up, and then there was Big Bang Rules 4 degrees K. I wish we had that one again, but you never know. It might just appear.
Sutherland, get on it. Lovely. Okay. Well, thank you very much for this evening, David. You are an excellent public speaker. I've really enjoyed your jovial manner. The happiest planet of all.
Thank you very much.
Thank you very much. Good night. And thank you, everybody from the SPA. Bear with us while we try to get these problems sorted. Maybe I'll move house. See you later, everybody. I'm going to end the broadcast now. Bye. Well done for channeling Patrick. Good night, everybody.